G'day, Mr. Bennett here. Today we're just going to be looking at the sine function, and this is a really important part of the course, is to actually understand this curve. Now, it's almost the same, obviously, with the cosine rule as well. But anyway, let's just have a look at this. Now, the function there, and we've actually done this activity in class where we've looked at what does the amplitude do, the B value, the C value, the D value. Now, we'll talk about that in a bit of detail. I'll just go through some stuff on the calculator. So when we start looking at a sine curve, a normal sine curve goes for a rotation of 360 or 2 pi, and it repeats this pattern. So when we go to our calculator over here, alright, so that's our general sine curve from minus 2 pi or minus 360 degrees up to 720 degrees. And when I graph this thing over here, obviously the first thing we're doing is we're going to change the amplitude. So 2 and then press sine x and graph that. So what we're seeing here is as that's graphing itself out, it's going to a height of 2, going to a height of minus 2. It's keeping the same period, but it's just doing that. And then obviously what we did in class was we went and looked at something like 4 sine x. We graphed that. And then that went to a height of 4, went down to a height of minus 4, up to 4, back down to minus 4. So it's still got the same period, looks identical, just goes higher over there. And then what we did in class, we looked at the idea of having a negative value. So if we put, say, something like negative 4 in there, sine x, and we graph that, so it's exactly the same as the sine 4x, but it's actually reversed. So instead of going up, it's coming down. So it inverts the graph there. Alright, so if we were thinking about what we had to say about the thing over here, well, A affects the amplitude, alright, but more than just the amplitude, what it actually does is that A basically equals the amplitude and also the direction. Alright, so obviously if it's a negative value, then what we do is we invert the actual graph itself. Alright, so the amplitude also determines the actual direction of our sine curve. Alright, so that was the first thing we did. So we're just going to go back in there. We'll clear all of those, apart from the first one. Alright, so you've got to get used to using your calculator and get really good at this. So if you forget, you can always come back and actually look at this. So then we looked at the B function. So what we said was something like sine of 2x. And we graph that. And then what we see when we do that is, this is our normal sine curve. That's 2 pi or 360 degrees, another. Alright, so over here we're getting 2 waves for every one wave. Alright, so we'll look at this section here. So we normally get 1 complete wave. Here we're getting 2 waves. Alright, if I now change that to be, instead of being 2, we go 3, and we graph that. Alright, so if I put a 3x there, instead of getting 1 wave, we're going to get 3 waves. Okay, obviously we talk about the period of the wave here. So we get 3 waves for every 1 normal wave that we've got. And then if we then go to something like 6, I'll just try that one there. And very quickly, just go back one bit, change it to 6. Then what we're going to see there is for every 1 normal wave, we're probably going to see 6 waves. Alright, so as that actually draws it, we might count them out and follow the graph. go 1, 2, 3, 4, 5, 6. Okay, so you're getting 6 waves for every one normal wave. Now, the important thing there, if we're looking at our B value tells us the period of the wave. Okay, so our B value is equal to the period of the wave, or it certainly determines the period of the wave. So what we know is the period has got a symbol T. Okay, so we know that B is equal to 2 pi over the period. Right, so that's equal to 2 pi on T. So if in the case where we have a value of 3, all right, so therefore if B is equal to 3, then the period of the wave is going to be 2 pi over T, so therefore T is equal to 2 pi on 3. Okay, so in other words, for every 2 pi you're going to get 3 waves, or for every 1 wave it's a third of 2 pi. Alright, so that will give you a bit of an idea about how to actually work out the period of a wave, which is really important. That tells you how often it will oscillate itself. So if we're looking at a yearly thing, that might be over 12 months, or if we're looking at a tide thing, that might be every 12 hours. Alright, so they've got different periods depending on that. Alright, so the next part of that in the formula here is to look at our D value. Alright, so let's just change that on a graph. So we'll clear all that, and we'll go and clear that graph there. Yeah. So we'll now put this here as sine x, and then we're going to add 3 to it. Okay, and we'll graph that. So here's our normal sine x. It's got a height of 1. It oscillates between 1 and -1. And all we did with our other graph was we now did sine of x plus 3. And so you can see that every point on that curve is actually being moved up 3. Every curve is being moved up 3. So the D value obviously translates the graph up and down. So let's just try another one. If we did sine of x, so sine of x, take 2, so we'd be expecting to see that translate that downwards by a factor of 2. So now it's translating between, or it's oscillating between -1 and -3. Everything's being moved down 2 points. Alright, so I think it's pretty straightforward to see the D value. Alright, so our D value shifts the curve up or down. Okay, so that's what that's doing. Now the next thing that we want to look at, and the last thing we're going to look at, is what the value of C does. Okay, now keep in mind when we start doing these graphs, quite often you do 2 things. You do something to maybe all 3, 4 or 4 variables here. So let's try one of these, okay, because we're using degrees, so I'm going to work out degrees here. So let's say I did sine of x, take 90. Okay, so I'm taking 90 away. So we have to look at what's actually going to happen to the curve here as I'm doing that. So here's our traditional, so we want to reference everything to our normal sine curve. That's the thing that we normally do. And the next thing we do is, it's moved it. Okay, so this graph would normally, start somewhere like that. It actually shifted my graph to the right by a distance of 90 degrees. Alright, so let's just do another one. Let's do sine of x, and then we go take, well, let's go add 180. Okay, we'll try that and see what actually happens. So there, what's actually happening here is that point that we'd normally start with is being moved that way, not 90 degrees, but 180 degrees. So it's translating it that way. Alright, so our C value translates our graph, it moves our graph in fact that direction to the right when I'm taking away. I'll just clear those two graphs and see what happens if I do a plus. Let's do this one here, make that a plus. And I'll, now if you don't want to delete it, all you have to do is go enter and it's no longer highlighted and it won't graph it. So again, here's our normal sine curve. Alright, so keep in mind what we're going to be doing throughout this topic is we're trying to model what's actually happening with these curves here. Alright, so if I went plus, what's actually happened, it's moved that point there back that way 90 degrees. Okay, so I think we probably have enough information now to make a statement about what actually happens with a curve. So our C value, okay, so that will translate the curve that way if the C value is, if it's take C, and it goes that way if it's plus C. Alright, so whatever the value it is, basically that's what we've got there. Alright, so now remember the formula is in fact x take C. So in other words, if we have a C value, right, and I can probably get rid of those. So if it's our C value is that, then a normal positive value, then it will translate it to the right. To get a negative, to get a plus C there, has to be take negative C. So if I have a negative C value, then it will translate it to the left. Alright, now obviously one of the key things that we want you to be able to do is to model what a curve would look like and use this formula to do that. Anyway, we'll be doing some more of that in class and certainly going to be involved in doing it in investigation. I hope you sort of get the concepts here. It's really important that you understand this stuff.